All right, let's dive in. We're going to start out with a little bit of a review of square roots, just to sort of refresh your memory about what a square root is. If we see this symbol, that means a square root. If we're after, say, the square root of 49, what we're looking for is what number multiplied by itself would give me 49. What number multiplied by itself would give me 49? Seven. Perfect, Ashley. So if we see the square root of 49, we can simplify that to 7. Some of you who have taken like an Algebra 2 level course or something similar might say, well, what about -7? That could be an answer too. And you're exactly right. We would have to consider plus and minus 7 if we were thinking of this in an algebraic sense. We're doing it with an eye on geometry. So when we look at a square root, we're typically looking at it as a side length of a shape of some kind, probably a triangle. And because it's a side length, we're only concerned with the positive. So we only need to worry about the positive square root, which would just be the 7. If instead we wanted to do something like the square root of 70, what number multiplied by itself would give me 70? I have no idea. You probably don't either. So we would use our calculator for that. And I want to make sure you can find the square root button on your calculator. Depending on the calculator you have, you'll either put in the 70 first and then hit the square root button, or you'll hit the square root symbol, the 70, and then either equals or enter or something like that. It kind of depends on which calculator you have. But I want to make sure you're able to find the square root of 70, which would be 8.366666. And let's just say, for refreshing our memories purposes, we wanted to round that to the nearest hundredth. We would find the hundredths place. We would look one space to the right. Since that number is 5 or bigger, we would round this up to 8.37. If there's anything in there that you're not sure of, didn't make sense, you're not sure where anything came from, you can't find the square root button, please don't hesitate to let me know. I also realize your square root button might have a little 2 right there in that spot. Sometimes the calculator will have a 2 there, sometimes it won't. All right, a little bit more review before we get into the meat of section 1.4. Solving equations is something that we'll do a little bit of in this section. And we've done some of that already, but this time we're going to solve equations that have squaring in them. So I do want to take a look at these two examples. The one on the left, it says 9 squared plus 7 squared equals x squared. Just as a reminder, I'm saying squared, that's an exponent there, and it means raised to the second power. If I want to raise 9 to the second power, 9 squared, that means take 9, multiply by itself, and you'll do 2 of them. So 9 squared is 9 times 9. Just as an exponent review, 9 to the third would be 9 times 9 times 9. We'd have 3 of them. Here in this particular case, we have 9 raised to the second power, which is 9 times 9, so that's going to be 81. So we can simplify that 9 to the second power, or 9 squared, and have 81. Again, if you see anything you're not sure of, anything that doesn't make sense, you just let me know. Then we get 7 squared. 7 to the second power, that's 7 times 7, that's 49. And over here we have x squared. If we're trying to solve that equation, we're trying to find the value of x. We need to get x by itself. So we can do some things here. We can simplify over here on the left. That 81 plus 49, we can go ahead and add those together and get 130. And that's x squared. I mentioned that we've done some solving equations before. When we saw something like 4x is 20, what we would do is, well, that means 4 times x To make times go away, I need to divide and do that to both sides. And if we had, say, 4 plus x equals 20, well, I want this 4 to go away. It's addition, so I'm going to subtract. So I do the opposite of whatever is there if I want to make that operation go away. To make multiplication go away, I'll divide. To make addition go away, I'll subtract. So here, in this case, I have x squared is 130. I need that squared to go away. What can I do to both sides to make squared go away? If you know, that's great. If you don't, that's okay. But if you know, throw it in there. Yeah, perfect. Excellent, Jenny. And I'm going to be a little specific with your language. You're exactly right. Square root 130. We're going to square root on this side because the square root cancels out the squared, leaving us just the x. And if we square root on the right-hand side, we have to square root on the left-hand side. And so we're going to take the square root of 130, and that's going to be 11.40175. And that keeps going. Here I was told to round to the nearest hundredth. So we'll do that. We'll go down there and we'll identify the hundreds place. That's where the 0 is. I'll look one space to the right. Since the number in that spot is 4 or lower, we're going to round this down to 11.40, rounded to the nearest hundredth. If you have any questions on that, let me know. Otherwise, we're going to go over and do the one on the right. Okay. Over here, just like before, anything we can simplify, we want to do that. So I have 13 raised to the second power. That's 13 times 13. So that'll be 169. There's nothing I can do to simplify the x squared. It just has to stay x squared for now. But the 13 squared becomes 169. And then on the right-hand side, 17 squared, which is 17 times 17, is 289. I'm trying to get that x by itself. This is an important thing when we solve equations. I'm trying to get x by itself, which means I need to get the term with x by itself. So as I look at this side of the equation, I'm kind of like peeling an onion from the outside in. And so the first thing I want to get rid of is this 169, because the first thing I want to do is get the x term by itself. So I need that 169 to go away. I've got plus 169 right there. What am I going to do to get rid of that 169 on the left-hand side of equals? What am I going to do to both sides? Outstanding, Jessica. You're exactly right. I'm going to subtract 169 on the left. The reason I do that is because these will cancel, leaving me just x squared. So I don't have my answer yet, but I'm closer. And then if I subtract 169 on the left, I also have to subtract 169 on the right. And when I do that, I get 120. Now I'm at the same place I was before. I have x squared. I want squared to go away. So I'm going to take the square root, because square root and squaring cancel each other out, leaving me x. If I square root on the left, I also have to square root on the right. And I square root that 120 and get 10.9544. And that keeps going. But I was told to round to the nearest hundredth. So we'll find the hundreds place. We're either going to round this up to 10.96 or round it down to 10.95. Those are the only two choices. I look one space to the right. Since that's 4 or lower, I'm going to round this down to 10.95. So I've solved this equation. I found out that the value of x that would make it true is 10.95. In the one on the left, I solved that equation. And I found out that the value of x that would make this true is 11.40. Do you have any questions on those before we go forward into the Pythagorean theorem? Perfect, Matthew. Thanks. Those new symbols are kind of fun. I like them. It's a great way to share feedback. Yes, great question, Hugh. And if I pronounce that wrong, you let me know. Question is, if it's 11.40, what if I just put 11.4? Well, these two have the exact same value as each other. So Canvas would consider that correct. So you could either put the 0 there or not. Either way would be just fine because they have the same value as each other. Excellent question. All right, let's talk Pythagorean theorem. First of all, you've already read about Pythagoras in section 1.1. Ancient Greek mathematician, ran a school. The way the schools worked in ancient Greece was if anybody in the school came up with an idea, theorem, something like that, it got credited to whoever ran the school. So we can't be sure that Pythagoras himself came up with this. It's likely, but we don't know that for sure. It could have been one of the students at the school. We also know from some clay tablets that the Babylonians knew about this theorem a long time before Pythagoras. Now, they were in different parts of the world. They couldn't have communicated with each other. So somebody in the Babylonian world was aware of what we now call Pythagorean triples because they're on clay tablets from the ancient world. But Pythagoras gets credit for this, and we call it the Pythagorean theorem. And you may know it as a squared plus b squared equals c squared. And I'm okay with that, but I don't love it. And I'll show you why in just a few minutes. If a squared plus b squared plus c squared is something you're comfortable with and you know it, I'm not telling you that anything about that is wrong. But I am going to show you why I prefer something else better. When we look at a right triangle, 90-degree angle in the corner. So Pythagorean theorem only works with right triangles. We'll establish that first. There are three parts of anatomy to this right triangle. There are two parts that are legs, and then the longest side, the one that is across from the 90-degree angle, that's called the hypotenuse. So we have those pieces of our right triangle. And the way that I'm going to express the Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. It takes a little bit longer to say than a squared plus b squared equals c squared. But the reason I like it better is this. A squared plus b squared equals c squared is great as long as your legs are a and b and your hypotenuse is c. But those are variables. They can be put anywhere. If I call this one C and this one B and this one A, now it's C squared plus B squared equals A squared. Uh-oh, now I'm all goofed up. So that's the reason I don't love A squared plus B squared is C squared. It's great. It works. There's nothing wrong with it. But it only works if C is your hypotenuse. What will work all the time, no matter what you call them, is leg squared plus leg squared is hypotenuse squared. Let's take a look at how this works. Find the length of the hypotenuse in the triangle below. Round your answer to the nearest hundred. So here I have this right triangle. I know the Pythagorean theorem is leg squared plus leg squared is hypotenuse squared. I can see that it's the hypotenuse here that I don't know, so I could call that x. You could call it c. You could call it hypotenuse. You call it whatever you want. It's a variable. What I want you to do is find the length of that hypotenuse and round your answer to the nearest hundred. I'm going to set up a poll for this one. Use that formula, and the problem solving we did as a review to find the length of that hypotenuse. I'll give you a little time on this one to find the length of the hypotenuse of that right triangle. What you want to do here is you want to use the Pythagorean theorem to set up your equation and then solve that equation. We know both of the legs. We're looking for the hypotenuse. Don't forget, when you get to the place where you have x squared, you've got to square root both sides to get x by itself. If you solve this and come up with an answer that's not one of the ones shown, pick the one that's closest to yours. What that does is that lets me know you've had enough time to solve it so that I can know that it's time for us to start talking about the problem. So if you come up with an answer and it's none of the ones that are given, that's okay. Pick the one that's closest to yours, and that lets me know that you had enough time to solve it. As far as not having the correct answer goes, when we work through it together, maybe it'll all get cleared up. And if it doesn't, make sure you ask whatever questions you have. Let's go another, let's say 15 seconds on this, and then we'll talk about it together. Let's see where we are. Not unanimous, but definitely strong agreement. That's a good sign. Very good. All right, let's talk through this. And if you see anything that you're not sure of, don't hesitate to ask. All right, so we're going to use the Pythagorean theorem here because we have a right triangle. We know two sides, and we're looking for the other side. That's how we know to use Pythagorean theorem. I know two sides. I want to find the third one. And so here I have leg squared plus leg squared is hypotenuse squared. And I want to solve this for x. It wouldn't matter if you reverse these. You can put those legs in either order, and you'll see that as this plays out. So 7 squared to be 49, plus 12 squared to be 144, and that's going to be x squared. And now I have like terms over here. These two numbers, I can just add those together. The 149 and the 49 and the 144 is 193. So I have 193 is x squared. And at this point, you can see if I had these two reversed, it wouldn't matter. I'd still get 193 equals x squared. Really important to not forget the last step. The last step here is I'm trying to get x by itself. So I need to take the square root to get rid of squared, leaving just the x. And if I take the square root of the right-hand side, I also have to take the square root of the left-hand side. So we'll take the square root of that 193, and I get 13.89244, and it keeps going. But I was told to round to the nearest hundred, so we can do that here. We'll find the hundredths place. We'll look one space to the right. Since that's 4 or lower, we're going to round this down to 13.89. One thing I want you to keep in mind, it's easy to forget that last step of taking the square root and have 193 as an answer here. But remember, what we're doing is we're finding the length of this side of a triangle. Well, if one side's 7 and one side's 12, it really wouldn't make sense for that one to be 193. The triangle inequality would say you can't even make a triangle out of that. But more than that, it just would be a weird number. Like 712 and 193. We take the square root, we get 13.89, and what we just found out there is how long that side length is. And 13.89 makes sense when the other two sides are 7 and 12. So there's sort of a built-in check to make sure that you don't forget that last step of taking the square root. If you kind of look at your answer and see if it kind of, just in a general sense, does it fit with the other numbers in the problem? Similar to this, we might be asked, find the length of the missing leg in the right triangle below. Round your answer to the nearest tenth. You're welcome to try this one. I'm not going to do a poll here. I'm just going to do this one for us. But now what we're doing is we're looking for this missing leg over here. I have a right triangle. I know two sides, and I'm looking for the other side. That tells me to use Pythagorean theorem. I know two sides. I'm looking for the other side. This is a Pythagorean theorem question. So I'm going to use leg squared plus leg squared is hypotenuse squared. You could call this A or B or X. I just called it leg, so we'll go with that. So when I set up my equation here, let me know if you see something that doesn't make sense or you're not sure where it came from. But if I have leg squared, that's the one I'm looking for, plus the other leg squared is equal to hypotenuse squared. Hypotenuse is always the longest side. It's always the one across from the right angle. Now we'll solve this. All right, well, can't do anything with that just yet. 8 squared is going to be 64. 14 squared, well, let's see. 14 is 196. This is a little bit more work than the last one, because here I have to subtract 64 from both sides. I didn't have to do any subtraction on the last one, but here I need to subtract 64 on the left to get those to cancel. And if we subtract 64 on the left, we have to subtract 64 on the right. Where that gets me is now I have leg squared is 196 minus 64, or 132. I have one more step to go. I want to know how long this leg is. Right now, what I have is leg squared. So I need to make squaring go away. To make squaring go away, I'm going to square root on the left. Those will cancel, leaving me just the leg. If I square root the left, I have to square root the right. If I square root that 132, then we get 11.4891. And it keeps going. And I was told to round to the nearest tenth. A little bit different this time. Anytime you're taking a quiz, make sure you pay attention to where you're supposed to round. You want to make sure you round wherever you're told to round. Here it's the 10th, so we'll find the 10th place. We'll look one space to the right. That's 5 or bigger, so we're going to round this up to 11.5. Our other numbers are 8 and 14. 11.5 is reasonable as an answer, so I feel pretty good about it. Are there any questions about what we did there to find that the length of that leg? All right, one more Pythagorean theorem question for you. I'll set up a poll for this one. Find the perimeter of a right triangle with one leg 12 feet long and a hypotenuse of 15 feet. So we've got a right triangle. We know one leg is 12 feet long. We know a hypotenuse is 15 feet. So I know 2 of the 3 side lengths in a right triangle. That means I can use Pythagorean theorem. Be a little bit careful here, though. This question asks for the perimeter of the triangle. I'll set up a poll for this and let you try it. So we know we can use Pythagorean theorem. That's how we're going to find the leg we don't know. And then don't forget to find the perimeter. I'll give you a little time on this one. This is our last Pythagorean theorem question. After this one, we're going to roll ourselves into the trigonometry part of the day. I'm thinking we'll go another 30 seconds on this, and then we'll talk about it. Let me know if you're working on it and need more time. Now let's see where we are on this one. Oh, wow, we're spread out all over the place. Okay, we better be very careful as we go through this one. Let's go take a look at this. All right, so you don't have to draw a picture here, but especially later on today, you're going to see that drawing a picture is going to be really important part of our problems. And to me, anytime I can take something from words and make a picture out of it, that's helpful. So I'm going to do that. So here I've got a right triangle. One of the legs is 12 feet long and the hypotenuse is 15 feet long. So I've got it labeled. And now what I'm asked to do is find the perimeter. Well, the first thing I've got to do if I want to find the perimeter is I need to know how long this leg is down here. And at this point, I've got a right triangle. I know two side lengths and I'm looking for the other. That means I'm allowed to use Pythagorean theorem here. That's going to be my tool. Leg squared plus leg squared is hypotenuse squared. So I'll do that. And I'll have leg squared plus leg squared is hypotenuse squared. If you're seeing something that you're not sure where it came from, don't hesitate to let me know. All right, now we can simplify. That 12 squared will be 144 plus x squared is 15 squared is 225. Now I'm trying to get x by itself. And just as a reminder, when we solve, I'm trying to get x by itself. So I need to get the term that has x by itself. So in this whole side over here, I want to peel this onion from the outside in. I need to get rid of that 144. That's a positive 144, so I'm going to subtract 144 from both sides. When I subtract 144 on the left, those cancel, leaving x squared. And when I subtract 144 on the right, 225 minus 144, I get 81. One last thing to do to solve this equation is I need to get rid of squaring. So I'm going to square root on the left. Those will cancel. Square root on the right. And when I do that, I get x is equal to the square root of 81, which is 9. This is good. I just found out that this x down here is 9. I found out that the missing leg had a length of 9. And that's great. That's really good. Something I'm going to remind you of a lot is make sure you answer the question that's being asked. If you were asked, what's the length of the missing leg? 9's your answer and you're done. The thing is, in this particular question, we weren't asked for that. We were asked for the perimeter of the triangle. To find the perimeter of the triangle, I need to add up those three side lengths. The perimeter here is going to be the 12 that I started with, the 15 that I started with, plus the 9 that I just found. And I'll add all three of those together and have 12 plus 15 plus 9. My perimeter, which is what I was asked for, is 36. Finding the 9 was great. And a lot of you did that and put it as your answer. That was a really important part of the process here. But what we were asked for was the perimeter. So we had a little bit more work to do to find out that 36 was the perimeter of that triangle. Let me know if you have questions on that. Otherwise, we'll move forward into our trigonometry part. Awesome. with trigonometry, we're going to be looking at right triangles also. So it fits into our whole day studying right triangles. The word trigonometry comes directly from two Greek words, trigon, meaning triangle, and metros, meaning measure. Literally, we are measuring triangles. It's kind of what we were doing with the Pythagorean theorem. I knew two of the sides. I wanted to find the third one, so I used Pythagorean theorem. Trigonometry is really useful in a lot of practical fields like carpentry, surveying especially, and you'll understand that when we work through some problems. Some of you may have seen trigonometry before. Some of you, it may be totally new. Either way, we're going to go through this, and with some practice and some effort, I'm confident that you have a really good chance of mastering this. Let's talk about our triangles first. We're going to be working with right triangles. So we're going to have a right angle in our triangle. And we're going to want to be able to talk about the angles and the side lengths in our triangles. So what we're going to have here is we're going to use capital letters to represent the vertices of our triangle. Or the angles that are there. This is angle A because it's up at vertex A. This is angle B because it's where vertex B is. And this would be angle C because that's where the vertex labeled C is. This is going to be sort of our standard triangle. Triangle ABC, that's a right triangle. And we are going to typically use C as our hypotenuse. The capital C will be the 90-degree angle in our triangle. We're not going to try to make it complicated on purpose. We're going to stick with this as sort of our standard triangle. Important to note, capital letters are used for the vertices and the angles. So angle A, angle B, angle C. And then the sides that are across from those vertices. So here's angle A. Across from there, that's where side A is going to be. And for side A, we're going to use a lowercase letter. And then when we get to angle B, side B is the one across from there. And then finally, when we get to side C, that's the one across from angle C. Across from is going to be really important for us. This across from, a word that we're going to use for that is going to be opposite. So you're going to hear the word opposite a lot. And essentially what we mean by the word opposite is the one that's across from it. If this is angle A, then this is the side that is opposite angle A. Over here, this is angle B, so this is the side that is opposite angle B, and so on. Another word that you're going to hear is the word adjacent. Adjacent is a word that is tough, sometimes tough for students. In daily conversation language, if two things are adjacent to each other, they are next to each other. And that's kind of how this works. If we look at our right triangle over here that we have all these markings on, and if it's okay with you, I'm going to clean those markings off so that we can kind of, start fresh and look at adjacent. So I've got this right triangle over here, and I've got angle A right here, up here in the top left. And I can see that down here, that's the side that is opposite angle A. And then, okay, what is going to be adjacent? Adjacent is the side that touches angle A that's not the hypotenuse. It touches angle A, but it's not the hypotenuse. That's the one that is adjacent to angle A. Now let's say we want to play the same game with angle B. So we've got angle B down here. Opposite angle B is over there, the one across from it. And then adjacent to angle B. Well, adjacent is the one that touches angle B, but it's not the hypotenuse. We're gonna get to do a lot of these, and we'll do a lot of labeling. You'll notice the hypotenuse doesn't have any labels at all here. And the reason for that is because it's always just gonna be the hypotenuse. We're gonna use the words opposite and adjacent quite a bit. We're gonna practice using those words, and I'm gonna help you figure out which one's which as we go through them. But I just want you to be kind of familiar with those terms before we go forward. All right, let's talk about the trigonometric ratios. On your calculator, and you may have heard these words before, you may have seen these buttons on your calculator before, we have 3 trigonometric ratios that we're going to use in our study of trigonometry. The first of those is sine. It's pronounced like sine. And the abbreviation is SIN. You probably have a button on your calculator that has that on it, and it's for finding the sine. Next up is cosine, and it's pronounced cosine. And its abbreviation is COS. And then finally, we have tangent down here at the bottom, and it's pronounced just like it looks, tangent. Now you might be thinking, okay, that's great. What are these things? It would be a perfectly reasonable thing to be thinking. And the sine of any angle is going to be the side that is opposite that angle divided by the length of the hypotenuse. So the sine of some angle is going to be a number. It's going to be the length of the side opposite divided by the hypotenuse. And then the cosine, you might have guessed, is going to be the length of the side that is adjacent to that angle divided by the hypotenuse. And then finally, we have the tangent of an angle, which is opposite over adjacent. A couple of things I want to say before we go forward. All of these are side lengths. This is the opposite side. It has a length. This is the hypotenuse. It has a length. This is the adjacent side. It has a length. Hypotenuse has a length. Opposite is a length. Adjacent is a length. So those are all just numbers that we're going to use when we look for the sine, the cosine, and the tangent. And we'll look at an example of that should help a lot here in just a minute. Another thing is, if you look at, okay, you're telling me that sine equals opposite over hypotenuse. You're telling me that cosine equals adjacent over hypotenuse. And you're telling me that tangent equals opposite over adjacent. That's all true. Feels like a lot to remember, and you're not wrong. But everything in this box, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All of that can be remembered with one little word. SOHCAHTOA. And what SOHCAHTOA is a reminder to us that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So everything in this box is right here in SOHCAHTOA. And SOHCAHTOA is really easy to remember. SOHCAHTOA. With that in mind, let's look at an example of finding sine, cosine, and tangent of a certain angle. I think once we put some numbers on this, if you're kind of overwhelmed right now, that's not unusual. We're going to put some numbers on this, and that should help a lot. And you let me know if it doesn't. So if we want to find the values of these trigonometric functions, the first thing we're asked to find here is the sine of angle A. In order to find the sine of angle A, we have to remember Sine, which one is sine? I don't know. Wait, sine, cosine, tangent. SOHCAHTOA. The sine of an angle, the sine is opposite over hypotenuse. So the sine of angle A is opposite over hypotenuse. So I go over to my triangle and I say, okay, here's angle A. Opposite angle A is the one down here across from it. That's opposite angle A. The hypotenuse, that's easy. That's just the longest side over here. So I know the side opposite angle A is 12. The hypotenuse is 37. So the sine of angle A, opposite over hypotenuse, is 12 over 37. I'm going to pause right there for a minute and give you a chance to ask whatever question you want. And then I'm not going to do a poll for it. I'm just going to ask you. Feel free to type this in. The next one we're looking for is the cosine of angle A. If you're doing great with this and you're really comfortable, what's the cosine of angle A? If you're still kind of unsure, that's okay. And if you have no idea what just happened, make sure you ask questions. If you're still kind of unsure, we're going to do a lot more examples and you'll see it. If you're really comfortable, tell me what the cosine of A is. And if you're not at all comfortable, you can ask me questions and we'll work on it. Very good, Kevin. Ashley, that's terrific. When we're talking about angle A, right? We're talking about angle A right here. Well, this is the side that's opposite because it's across from it. I know this one's a hypotenuse. So maybe some of you are really comfortable with our formal definition of adjacent. It touches the vertex, but it's not the hypotenuse. That's fantastic. But you know what? If you're not okay with that, if you're like, I don't know what that is, if this one we can label as opposite and this one we can label as hypotenuse, then by default, just, we've eliminated this has to be adjacent. Even if you don't really know the formal definition of adjacent, if you can identify that that's the opposite and that's the hypotenuse, then the other one has to be the adjacent. So we can label triangles that way with no problem. And now the cosine of angle A, well, that's adjacent over hypotenuse. Well, how the heck did you know that? Oh yeah, because SOHCAHTOA. Cosine is adjacent over hypotenuse. So cosine is adjacent over hypotenuse. And I look at my triangle. Well, the adjacent is 35. The hypotenuse is 37. So the cosine of angle A is 35 over 37. Now, things get a little bit different here when we look for the tangent of angle B. Now, when we're talking about opposite, adjacent, and hypotenuse, we have to realize now we're talking about these things in relation to angle B, because now we're asked for the tangent of angle B. Well, angle B is down here. So in this case, now that I'm talking about angle B, opposite is over here. Hypotenuse is still the longest side, and I'm not sure I really understand what adjacent means, but if this one's hypotenuse and this one's opposite, then this one has to be adjacent. Okay, what is the tangent? Well, SOHCAHTOA tells me that tangent is opposite over adjacent. So that's opposite over adjacent. And relative to angle B, remember, we're talking about angle B now. Opposite's over here. That's the 35. And adjacent to angle B is this 12. So the tangent of angle B would be 35 over 12. Before we go forward, I want to give you a chance to ask any questions that you might have. If you're doing great, that's awesome. But if you have any questions about what we just did there, using SOHCAHTOA and opposite, hypotenuse, and adjacent to find those values, if you're doing great, that's awesome. Okay, okay. You know, I'm going to ask you some polls in a little while, and I'm going to find out if you're telling the truth. Okay, so our calculator is going to be really important for us in this section. Those sine, cosine, and tangent buttons that are on your calculator are going to be really important for us. I want to make sure you can use them correctly. And also, I want to make sure that your calculator is in degree mode. The way that we're going to find that out is I want you to find the sine of 30 degrees. So on your calculator, and it depends on which calculator you have, you might enter 30 and then hit the sine button, or you might type in sine 30 and then hit your enter or equals or whatever button you might have for that. I want you to actually physically do this, and it might take us a little time here to get everybody on the same page, but it's worth it, I promise. What I want you to do is find the sine of 30 degrees, either by typing in 30 and hitting the sine button, or sine 30 and hitting enter. And it just kind of depends on how your calculator registers stuff. If your calculator lets you type a straight line of things and then you hit enter, that's this approach. If your calculator it shows one number at a time, that's all it does. I can't type stuff on it. Then this approach. Both are great, both are fine, no advantage or disadvantage either way. When you take the sine of 30 degrees, I want you to get 0.5. If you get negative 0.988, and it keeps going, your calculator's not broken, you're not doing anything wrong. There's another way to measure angles. We're going to measure angles in degrees, but you can also measure angles in radians. It's very common to do that in a trigonometry course. We're not going to use that though. And if you get negative 0.988, it means your calculator's in radian mode. We don't want that. We want to make sure you're in degree mode. So take a minute, find the sine of 30. If you're getting 0.5, you're in great shape, you're good. If you're getting negative 0.988, you're in radian mode, and we want to fix that. Because if you're in radian mode, every example we do from now till the end of class is going to have the wrong numbers in it. Your calculator is going to be giving you different numbers than we show you. And it's strictly because your calculator is in radian mode instead of degree mode. So if you're getting this, please tell us. We'll get you squared away so that you're in degree mode. And then all the numbers that we do as we go through these problems for the rest of class are the same numbers you're going to get on your calculator. If everybody's in degree mode and sine of 30 gives you 0.5, that's awesome. We can go forward. Kind of feels like that's where we're at. Okay, let's keep going. Little bit of review of solving equations before we get into using those trigonometry functions. I want to look at two different types of equations. One of them is 10 equals a over 4, and the other one is 10 equals 4 over a. These look very similar to each other, but the one on the left, a key feature of this one on the left is that the variable is in the numerator. The one on the right, the variable is in the denominator. Now, these are both fine. We're going to encounter both of these as we go through the rest of section 1.4. We're going to see both types. When the variable is in the numerator, it's a very quick and easy solving process. When the variable is in the denominator, it's a little bit more work. I want to make sure you're able to solve both types because we're going to see both types. We don't get to choose where the variable goes. Sometimes it's going to be in the numerator, which is a huge relief. Great news. Sometimes it's in the denominator, which means, well, I can solve it. It's just going to be a little bit more work. Let's look at these two so that you see what I mean. The one on the left, it says a divided by 4. So to get that a by itself, to solve for a, what I need to do is I need to make division go away. So I'm going to multiply by 4. If I multiply by 4 on the right, I also need to multiply by 4 on the left. And on the right-hand side, those 4s cancel, leaving just the a. And on the left-hand side, I have 4 times 10, which is 40. Simple, done, that's it. All I had to do was multiply by 4, and I got my answer. Over on the right, though, it's not quite that simple. The first thing I've got to do is get that variable out of the denominator. So the first thing I've got to do is multiply by a on both sides. Any of you that have been through a course, Algebra 2 or higher, will say, you can't do that. What if a is 0? You can't do that. Well, we're talking about side lengths of triangles. So a is always going to be a positive number, so it's perfectly legal for us to do this. When we do this, what's going to happen is those a's are going to cancel, leaving me a 4. And on the left-hand side, I have a times 10 or 10 times a. Not quite done yet. I have one more step to do. Now, in order to get a by itself, I have 10 times a. I'll need to divide by 10 on the left, divide by 10 on the right. When I do that, the 10's cancel, leaving me a. And I get 4 divided by 10, which is 0.4. Neither one of them is beyond our skill level. It's just when we set up a problem and we recognize that, hey, the variable's in the numerator, it's like, awesome, I'm almost done. When we set up a problem, we realize the variable's in the denominator, I can do it. It's just going to be a little more work, and that's okay. I want you to be aware of that the solving processes are a little bit different depending on where the variable is in our problem. All right. Finally, we get to solve a problem using trigonometry. We're given this triangle over here on the right. It's a right triangle. And what we're told to do is find a to the nearest hundredth. My first thought is, hey, right triangle, great. I can use Pythagorean theorem. If I know 2 of the 3 sides, I can find the 3rd side using Pythagorean theorem. Problem is, I only know 1 side. Pythagorean theorem's no good here. When I'm given 2 sides and I'm looking for a 3rd side, Pythagorean theorem. That's not the case here. In this case, I've been given an angle and a side length. That's when I know I'm going to use trigonometry. So when do I even know to use the trigonometry? It's when we're given an angle and a side length. That's how we'll know. All right, so I've got this right triangle over here. And let's see, I'm supposed to find side A. So I'm looking for this side down here. And this is the side that I know. I've got to figure out which trig function to use. You know what? Before I start any of that, before I do anything, I'm going to look at this picture and, okay, that's the angle that I know. I can look at this triangle and I can see that there's my 90. So this one's the hypotenuse. This is the angle I know. So down here, that is opposite. It's across from the angle. It's the opposite. And if I know this one's the hypotenuse and this one's the opposite, then this one is the adjacent. I've got everything labeled. I know an angle and a side length, which means I'm going to use trig. And I'll tell you, for a lot of students, the hardest part of any of these problems is deciding whether to use sine, cosine, or tangent. So we'll take our time in deciding whether we're going to use sine, cosine, or tangent. The way we decide is with SOHCAHTOA. So whether I'm going to use sine, cosine, or tangent is not a guess. It's not a guess at all, and please don't turn it into a guess. SOHCAHTOA tells us which trig function we need to use. In this particular problem, I know this is 15. I'm trying to figure out A. With that in mind, does anybody know which trig function we're going to use? And that's all I want you to tell me is which trig function we are going to use here. If you don't know yet, it's totally fine. We're going to practice a lot. So which trig function are we going to use? Given that we know 15 and we're looking for a. If you don't know, it's okay. Like I said, we're going to practice a bunch of these. And you don't have to set up an equation yet or any of that. You just have to let me know which trig function you think we should use here. Cameron said sine. Miranda says cosine. Okay, so let's take a look at what we've got here. Sine is opposite over hypotenuse. Well, I need to find the opposite. I don't know the hypotenuse, so I am not using the hypotenuse here, so I'm not using sine. Cosine is adjacent over hypotenuse. I know the adjacent, so that's useful. I'm going to use that one. But I don't know the hypotenuse, and I'm not looking for it. So I'm not going to use the hypotenuse, so I'm not going to use cosine. Tangent is opposite over adjacent. Opposite's the one I'm looking for. Adjacent's the one I know. So that's the trig function we're going to use here. We're going to use tangent. And it's because I'm looking for the opposite. I know the adjacent. So opposite and adjacent are the two ones I care about in this particular problem. And it's not a guess and it's not random. You'll notice, I'm not looking for the hypotenuse. I don't know what the hypotenuse is. So I'm not using hypotenuse. And that throws out sine and it throws out cosine, so it must be tangent that I'm going to use here. The equation we're going to set up is this, that the tangent of this 22-degree angle is equal to, well, let's see, tangent is opposite over adjacent. So that's opposite, the thing I'm looking for, over adjacent, the one that I know is 15. I'll walk back through that real quick. So what we did here is this. We started out with this picture, and I was told to find side A. All right, I want to find that missing side length. So what I had to do was go, okay, here's the angle I know. I'm going to label everything based on that angle. Hypotenuse, across from it is the opposite, and so this one here then must be the adjacent. All right, I'm supposed to find side A, which is this one down here, and I know this one here. So those are the two sides I care about. I only care about two of the sides, the one I'm looking for and the one that I know. The one I'm looking for is opposite. The one that I know is adjacent. And so I look in SOHCAHTOA for this, and the only place I see it is here where tangent is. So we're going to use tangent. Yeah, we know the tangent of an angle is opposite over adjacent. Well, how do you know that? Because TOA tells me tangent is opposite over adjacent. So I set this up as opposite over adjacent. Opposite is the thing I don't know called A. Adjacent is the thing that I do know that's going to help me, which is 15. And so now I have my equation set up. What I've done is I've gone through and I've taken this picture and I've turned it into an equation that I can solve. Once I have an equation I can solve, I can find out what A is. The first thing we're going to do is we're going to use our calculator to find the tangent of 22 degrees. When I do that, I get 0.4040 26226. Your calculator might have more decimals than that. It might have less decimals than that. But we get that is equal to A over 15. I'm trying to find out what A is. So I'm trying to get A by itself. What I have right now is A divided by 15. So to make that divided by go away, I need to multiply by 15 on both sides. When I do that, the 15s are going to cancel, and I'm going to be left with A is equal to that really long decimal that's sitting on my calculator multiplied by 15. Here's a really nice thing in these problems. When I take the tangent of 22 and I get this really long decimal, I'll just leave it on my calculator. I only have one more step to go. I'll multiply by 15 and I'll have, let's see, that's 6.0603, and that keeps going. I was told here to round to the nearest hundredth. We don't do any rounding till we get to the very end. No rounding till you get to your answer. So we have this really long decimal that we have to deal with. We're keeping all of it. The only rounding we're going to do is when we get to the very end. I'm going to round to the nearest hundred. So I'll find the hundreds place. I'll look one space to the right. That's 4 or lower. So we're going to round this down to 6.06. What we just did here was this. We said, okay, if I have this triangle, and in this triangle, I know that I have a 22-degree angle right here, and I know that this measure is 15, how long is this side length down here? And by knowing this side length and this angle measure, I can find out this side length. You can see how this is extremely valuable in surveying, for sure. When the guy's out there with the little thing on the tripod and he's measuring angles, he's doing this. He's doing trig to figure out how far away something is. One thing I want to notice or mention before we go on to the next thing is this. When we set up our equation, our variable was in the numerator. That was great news. That meant we only have one more step to do. Perfect. All I'm going to have to do after I find the tangent of 22 degrees and I've got the variable in the numerator is just one more step. Just multiply both sides by 15, round, and we're done. If the variable's in the denominator, we can do it. It just takes a little bit more work, and that's what we're going to look at next. We have that same triangle over here, 22-degree angle, and we know that that side length AC is 15. This time, we're asked to find side C. So we're still working with angle A. We're asked to find side C. Side C is my hypotenuse. I'm going to label this triangle real quick here. So here's the angle I know. I know this is the hypotenuse because it's across from the 90-degree angle. And then across from angle A is going to be the one that is opposite. And that means the other one must be adjacent. So I've got it labeled. Now I'm ready to go. Okay, I look at this and I see I know an angle and a side. Can't use Pythagorean theorem. I'm going to have to use SOHCAHTOA here to help me figure out which trig function to use. In this particular case, I was told to find C. So now I'm looking for this one, and I know this one. My question to you is, which trig function are we going to use here? Sine, cosine, or tangent? I promise it's not a guess. Let SOHCAHTOA be your guide here. Which trig function, Xavier's got sine up, which trig function should we use? SOHCAHTOA is going to tell me. Mariana says cosine. Kevin, cosine. Jenny, cosine. All right, we got some cosines coming in. Let's take a look here. So as we look at this and we're making our decision, the one that I know is the adjacent. The one that I'm looking for is the hypotenuse. So it's adjacent and hypotenuse that I care about in this particular problem. So I need to look for the trig function up here in SOHCAHTOA that has adjacent and hypotenuse in it. Sine has opposite and hypotenuse. I'm not using opposite, so that's no good. Cosine has adjacent and hypotenuse. Hey, adjacent's the one I know, hypotenuse the one I'm looking for. I'm going to use cosine here. So that's how we decide which trig function to use. What side do I know? What side am I looking for? Which trig function has those two in it? And here, that's cosine. And so the cosine of this 22-degree angle is going to be, let's see, cosine is adjacent over hypotenuse. So adjacent, that's the 15, over hypotenuse, that's the c. What I've done now is I've gone from this picture and I've turned it into an equation that I can solve. I'm going to solve that equation and I'll know how long the hypotenuse is. Great news. I took a picture and turned it into an equation. If there's any bad news, variables in the denominator, dang it, I can do it. It's just more work. Okay, well, let's do it then. The first thing I need to find is the cosine of 22 degrees. And we'll do that. And if you're seeing different numbers than these, it may be a calculator issue. That's going to be 0.92718 3855. And that's going to equal 15 over c. Let me know if you see something that doesn't make sense, you're not sure where it came from. When the variable's in the numerator, it's great. We just leave that number on the calculator. We know there's only one more step and we're done. When the variable's in the denominator, it's kind of bad news because there's more work to do. And part of the work is that we actually have to write that number down. First thing we'll do, though, is we need to get the variable out of the denominator. So we're going to multiply by c on both sides. These will cancel. And now what I've got is this really long decimal times c is equal to 15. Again, if you see something that you're not sure where it came from, please let me know. Okay, I'm trying to get c by itself. I've got this whole long decimal here multiplied by c. I need multiplication to go away, so I need to divide by that really long decimal. If I divide by that on the left, oh, that's the cosine of 22 degrees. That's where the decimal came from. So we used our calculator to find the cosine of 22 degrees. If I divide by that really long decimal on the left, I also have to divide by that really long decimal on the right. And that's why we have to write it down, is so that we can do 15 divided by 0.92718 3855. When we do that division, on the left-hand side, those cancel, leaving just the c. On the right-hand side, 15 divided by that decimal gives us 16.1780, and it keeps going. But we were told to round to the nearest hundredth. We don't do any rounding till we get to the very end. Now we're at the very end, so we can round to the nearest hundredth. So find the hundredths place, look one space to the right. Since that number is 5 or bigger, we'll round this up to 16.18. How long is the hypotenuse in this triangle? It's 16.18. What we just did here, what we just found is this. If we know the angle right here is 22 degrees, and this side length is 15, then the hypotenuse length must be 16.18. All right, let me know if you have questions on that before I have you try one. Because you knew the polls were coming. They're on their way. And it's fair. There's a lot to keep track of in here. SOHCAHTOA is probably entirely new for a lot of you. Just remember, there's a process. We're trying to turn that picture that's over here. We're trying to turn this picture into an equation we can solve. The way we do that is by figuring out what it is we have, what it is we're looking for, and which trig function to use. Yeah, if you wanted to, you could. Sure. You could use tangent to find out A first and then find C. Yeah, yeah, you could. I'm not sure that's an approach very many people would take, but if you wanted to, yeah, you could. Just make sure you don't round your answer to A. Because if you round your answer to A, then C will probably be off by a little bit. All right, I'm going to have you try one. Given a right triangle ABC, where C is the hypotenuse, if angle B, we know it's an angle because it's a capital letter and because we're told degrees, is 38 degrees, and side C, we know it's a side because it's lowercase, is 50, find B. We're looking for a side length. So, given right triangle ABC, where C is the hypotenuse, if B is 38 degrees and C has a measure of 50, find side B. Round your answer to the nearest hundredth. I'm going to sketch the picture for you and then turn you loose to try to find the side length of B, and I'll set up a poll for this one. I think in all of these trig function questions, drawing a picture is really important. Our standard triangle is going to be A up here, B down here, and C is the right angle. You could switch A and B if you wanted to. There's not really an advantage to doing that, though. And we're told C is the hypotenuse. So absolutely, without a doubt, we know C, little c has to be the hypotenuse, and capital C has to be the angle that's the 90-degree angle. We're told angle B is 38 degrees, so we have a 38-degree angle down here. And we're told that C over here has a length of 50. So instead of calling that C, we'll go ahead and call it 50. That's 38 degrees, and that's 50. And then what we're trying to find is side B. Oh gosh, which one's side B? Side B is the one that is across from angle B. So that's the one we're looking for. All right. So with that information, I'm going to leave you to it and set up a poll for this one. I don't think it's easy, but I do think you can do it. So use SOHCAHTOA to figure out which trig function to use, set up your equation, and then solve to find B. Take your time on this, and remember, if you get an answer that's not one of the ones shown, that's okay. Just pick the one that's closest to yours. And then once we have once I get a sense of, how fast everybody's doing and how much time you need, then I'll know when we can talk about it. One thing you'll find with these is there are quite a few things to do. Nobody expects you to look at that triangle and just know what B is, or to do something like, I don't know, 50 divided by 38, because that we're not just going to sort of pick something to do with the numbers. Instead, we know there's a process. I know an angle and a side length, so I'm going to use trig, which means I'm going to use SOHCAHTOA to figure out which trig function I'm going to use. And then it's going to be some trig function of that 38-degree angle is equal to some fraction. And then I'm going to solve my equation for the variable, and that's going to be the answer to my question. But there's a process here. It's not something that happens automatically or quickly even. There's a process. Also, I do want to mention, when we do the polls in class, except for in extremely rare circumstances, which I can't even think of one, but these are the types of problems you can expect to see in homework. These are the types of problems you can expect to see on a quiz and on an exam. And so practicing them when we do them in class is a great way to kind of see, am I understanding this? Am I doing okay with this? What questions do I need to ask? Where am I going wrong? Like, doing the polls in class has a lot of value. It has a lot of value for me because I get a sense of, there was the one that we did earlier with the perimeter of the right triangle. We did Pythagorean theorem, where it's like, our answers are all over the place. We better go real slow as we talk about this and maybe even talk about something over again. Or another question that we had that was just finding the hypotenuse of the right triangle, where pretty much everybody got it right. Then that lets me know that too. So I get a lot of information from the polling, and so do you as far as where you stand. I'm thinking we'll go another 20 seconds on this. If you need more time, you can let me know, and then we'll talk through it. I guess the main thing out of that last bit was I'm really encouraging you to do the polls. There's no stakes at all, and it's a great way to kind of see how you're doing and where you're at. All right, let's see where we are on this as a class. Okay, not unanimous, but pretty strong agreement there on 30.78. Let's go take a look at this and see if we can iron out any difficulties you might be having, or if you weren't sure what to do, clean those up. Please ask questions if you have them. All right. So I'm given this information, given a right triangle ABC where C is the hypotenuse. Immediately, I'm going to draw a picture. That's step one before I even know anything else. And then I draw my picture, and I'm told that if angle B is 38 degrees, okay, so that's down here, 38 degrees. C is 50. We want to label that. Find B. So I'm looking for B. I think it's a really good idea to label the sides of the triangle. That will help you decide which trig function to use. So, okay, well, I know this one's the hypotenuse because this is the angle I know. Across from that, this is the opposite side. It's across from the angle that I know. And if this one's opposite and this one's hypotenuse, it's great if you know the definition of adjacent, but even if you don't, this one must be adjacent then. Okay, in this particular question, I've got to decide which trig function to use, which means I'm going to let SOHCAHTOA tell me which trig function to use. And just a reminder of SOHCAHTOA here, what's going on is, if it's opposite and hypotenuse, I'm going to use sine. If it's adjacent and hypotenuse, I'm going to use cosine. If it's opposite and adjacent, I'm going to use tangent. So there's no guesswork here. It's very straightforward. In this particular problem, I know the hypotenuse. I'm looking for the opposite. So the trig function I'm going to use is the one that involves opposite and hypotenuse. The only one that involves opposite and hypotenuse is sine. So when we set up our equation here, we're going to use the sine of that 38-degree angle is going to equal, see, sine is opposite over hypotenuse. Opposite's the thing I'm looking for over hypotenuse, which I know is 50. And now what I've done here is pretty good. I went from these words to a picture to an equation. I boiled all this down to just this thing right here, and all I need to do is find out what b is, and I've answered the question. First thing I've got to do is find the sine of 38 degrees. That's a calculator thing. And let's see, I get 0.6156, 61475. And that is equal to b over 50. Great news, though. My variable's in the numerator. Awesome. So all I need to do is one thing to get b by itself. I just need to multiply by 50 on both sides. On the right-hand side, those cancel. And then this number that's already sitting there on my calculator, I'll just leave it there. All I need to do is multiply it by 50. And I get 30.7830. And that keeps going. That's equal to b. And I'm told to round to the nearest hundredth. So we will find the hundredths place, look one space to the right. That's 4 or lower. So we're going to round this down to 30.78. Okay. Before we go forward to look at a different type of question, let me know if you have any questions about what we did there. If you're not sure how we solved it, if you're not sure where the numbers came from. All right, terrific. All right, I mentioned that drawing a picture is going to be really important because not all our problems are going to be you're given a right triangle. Sometimes you're going to see something like this, and we're going to have to go from these words to a picture to an equation. It's okay, a little bit of practice, and we'll read the question multiple times. A tree has fallen over and is leaning against a wall so that it makes a 50-degree angle with the ground. If the tree is touching the wall at a height of 8 feet from the ground, how tall is the tree? First, nobody expects you to say 9 feet. Nobody expects you to come with an answer right now. We got a lot of things to do here. The first thing we're going to do is draw a picture. So let's see. It doesn't have to be a work of art, I promise. Tree has fallen over and it's leaning against a wall. Okay, so tree has fallen over and it's leaning against a wall. All right, not artistic, but it'll do. Got my tree leaning against the wall. And it says it makes a 50-degree angle with the ground. So if you'll notice, the tree, it makes an angle with the wall, but it also makes an angle with the ground. Down here at the ground, this tree makes a 50-degree angle. And I'll read this over and over again as I draw the picture. I expect the same will probably be true for you. Tree's falling over, it's leaning against the wall, makes a 50-degree angle with the ground. What does that mean, angle with the ground? Well, it means the tree makes an angle here with the wall, and it makes an angle here with the ground, and it's the angle with the ground that is the 50-degree one. So that's the one I want to label. If the tree is touching the wall, okay, here's where the tree is touching the wall, at a height of 8 feet from the ground. So from the ground to where the tree is touching the wall, that's 8 feet. And then the question is, how tall is the tree? So in other words, how long is this? Which we don't know. We can call it X. We could call it anything else, but I'll just use X. Now I look at this and I kind of step back for a minute and I go, hey, that's a right triangle. If I knew two sides, I'd use the Pythagorean theorem, but I don't. I know a side and an angle, so I'm going to use trig. So what I'm going to do here is I'm going to use SOHCAHTOA to figure out which trig function to use. To help me with SOHCAHTOA, I'm going to label my triangle. All right, so let's see here. That's my right angle, so this one's the hypotenuse. It's across from the right angle. And then this is the angle I know. So relative to that, the one across from it is called opposite. And then if I know the hypotenuse and I know the opposite, then this one down here is adjacent. Okay, got everything labeled. Now I got to figure out which trig function to use. Which trig function do I want to use here? It's the only question I'm going to ask y'all about this question. Which trig function do I want to use? Yeah, we've got one vote for tangent from Miranda. And maybe this makes it more obvious for everybody to see. In this particular case, I know this one. I'm looking for this one. Which trig function do I want to use? And the reason I ask that over and over again is I find that students have no problem solving the equation once it's set up. The thing that they tell me that's the hard thing to do here is deciding which trig function to use. And I really don't want that to be a guess. Jessica says sine. All right, well, let's see. I know the opposite. I'm looking for the hypotenuse. So opposite and hypotenuse are the ones that I care about. As I look at my SOHCAHTOA up there, opposite and hypotenuse. Hey, that's the one, because this is adjacent and hypotenuse. I'm not using adjacent. This is opposite and adjacent. I'm not using adjacent. So it's got to be sine. It's the only one that uses opposite and hypotenuse. So sine's the one I'm going to use, and I'll set up my equation to be sine of that 50-degree angle is equal to, let's see, opposite, which is the 8, over the hypotenuse, which is the x. Great news. I went from words to a picture to an equation. If there's any bad news, my variable's in the denominator. That's okay. I can still solve it. And we'll go through the process to solve it. Let me know if you see something that doesn't make sense. Sine of 50 degrees is 0.7660. 44443. And that's equal to 8 over x. All right, trying to get x by itself. I've got to get it out of the denominator. So the first thing we'll do is multiply both sides by x. What that does on the right-hand side is gets the x's to cancel. And so now I have 0.7660 44443 times x is equal to 8. And now I need to divide both sides by that really long number. It's not pretty, but it's okay. 660 44443. And if I divide by that on the left, I also have to divide by that on the right. On the left, those two things are going to cancel. And on the right, now I've got to do 8 divided by 0.7660 44443. And when I do that and round to the nearest hundredth, we get 10.44. So how tall is the tree? It is 10.44 feet tall. Let me know if you have any questions about anything we did there to find out the height of that tree. Drawing a picture is important in these. Recognizing how tall is the tree, we're being asked for the hypotenuse of the triangle, the length of the tree. We have a few more we're going to do. Today is one of our longer days because it's stuff that I want to practice quite a bit. So hang in there with me. Angle of elevation and angle of depression. These are two topics that come up when we study trigonometry, and they're exactly what they sound like. The angle of elevation, anytime you see angle of elevation in a problem, it means the angle is drawn upward from horizontal. So angle of elevation means I've got a horizontal and my angle is upward from horizontal. So if you see angle of elevation, when you draw your picture, you know you're going to have something that looks like this in it. And that angle of elevation is this one right here, up from horizontal. As you'd expect then, an angle of depression is down from horizontal. So anytime you see angle of depression in a problem, it means you're going to have a horizontal line involved somehow. And there's going to be an angle that goes down from horizontal. And the angle of depression is going to be this one that goes down from horizontal. So that's what those two words mean. Angle of elevation, if you see that in a problem, means that you are going to have an angle that goes up from horizontal. Angle of depression means you'll have one that goes down from horizontal. Let's look at an example of those. The angle of depression, as soon as I read that, angle of depression, this is down from horizontal. When I draw my picture, I'm going to have an angle that goes down from horizontal. Okay, we read that there. The angle of depression from a helicopter to a landing pad is 28 degrees. The height of the helicopter is 1,000 feet above the height of the landing pad. Rounded to the nearest foot, what is the distance from the helicopter to the landing pad? We definitely want to draw a picture of this. Doesn't have to be a work of art. Mine won't be, I promise. I'm not even going to try to draw the helicopter. Instead, I'm going to do this. Helicopter. All right, so there's my helicopter. And it says the angle of depression from a helicopter to a landing pad is 28 degrees. So the angle of depression, that is down from horizontal. So here's my landing pad. And I've got this angle here that's the angle of depression. And I'm told that that angle is 28 degrees. Okay. The height of the helicopter is 1,000 feet above the height of the landing pad. Okay, so I know I'm making a right triangle out of this somehow. So the height of the helicopter is 1,000 feet above the height of the landing pad. So here's the height of the landing pad. So it's 1,000 feet above the height of the landing pad. So vertical distance straight up and down, 1,000 feet. And as I look at this, I can kind of see here, I've made myself a right triangle with the distance from the helicopter to the landing pad, the height of the helicopter above the landing pad, and the ground. There's my right triangle. Okay, and then it says, rounded to the nearest foot, what is the distance from the helicopter to the landing pad? So I'm trying to find this right here. All right, I made a right triangle, and so I'm going to go ahead and label that thing. When I label it, here's my right triangle. So across from the right angle, that's my hypotenuse. The angle, well, this is weird. I haven't seen this before. It's a very unusual situation. It won't happen to you very often, but it might come up with an angle of depression question. This 28-degree angle that they gave me, it's not in my triangle. Well, shoot. How does that help me? Here's how it helps me. These two together, because one of them's horizontal and one of them's vertical, those together make a 90-degree angle. So if this is 28, then I can find out how big this angle is over here. How big is this angle over here? Anybody calculate that for me? I know that this horizontal line and this vertical line make 90 degrees. If this one's 28, excellent, Miranda, I can say, okay, so together these two make a 90-degree angle. If I do 90 minus that 28, then the other one has to be 62. And it's because together they make 90. If this is 28, then this one has to be 62. Now, finally, I know the angle inside my triangle, and I know a side length. That's the angle I know. So this is opposite, which means this must be adjacent. by default. A lot of work in this question. I'm not going to lie to you about that. Okay. I'm going to use trig. I need to figure out which trig function to use. So there's SOHCAHTOA. And let's see here. The thing that I'm looking for is the distance from the helicopter to the landing pad. We'll call that x. That's the hypotenuse. The thing that I know is this vertical distance here that's 1,000, that's the adjacent. So if I know the adjacent and I'm looking for the hypotenuse, cosine is what I'm going to use, because that's the one that involves adjacent and hypotenuse. Now we're back to something that feels normal. Up till now, I was like, angle of depression, that's new. The angle I was given isn't in the triangle. That's new. We just need to subtract from 90, or what added to this would make 90, if you want to think of it that way. And now we're back to a normal thing where I know an angle, I know a side, and I'm looking for a side. I know this angle, I know the adjacent, I'm looking for the hypotenuse, so I'll use cosine. The cosine of that 62-degree angle is going to be, let's see, cosine is adjacent over hypotenuse. So that's my 1,000 over x, the thing I don't know. The great news here is I took a pretty complicated situation. Angle of depression. The angle I was given wasn't even in the picture and in the triangle I was going to use. But I drew my triangle, I made a picture, and now I have an equation to solve. I've done a ton of great work. There's variables in the denominator, which is not what I would prefer, but that's okay. I can solve it, and I'll go through this solving process. Cosine of 62 is 0.4694, 71563. And that's going to equal 1,000 over x. As we've done before, I'm going to multiply both sides by x to get the variable out of the denominator. When I do that, these cancel, and now I have this really long decimal times x equal to 1,000. Now I need to divide both sides by that really long decimal. Those cancel, leaving just the x. And then on the right-hand side, what I've got is 1,000 divided by 0.4694, 71563. And then rounded to the nearest foot. So that's the nearest whole number. We get 2,130. So the helicopter is 2,130 feet from the landing pad. The computers that are helping helicopters and planes fly are using this kind of math to kind of help them figure out how far away they are and what their angles need to be. One thing about this, it's a pretty complicated problem. There's no lie. If somebody happens to walk by when you're working on this, not only does it look impressive, it is impressive. So hopefully everything in there made sense. I want you to try one more problem. It'll be the last one for us today. And it's this. The angle of elevation from a spot on the street to the top of a building is 67 degrees. The distance from that spot to the base of the building is 30 feet. Rounded to the nearest hundredth, how tall is the building? I want to give you a minute or two to try to draw this on your own. And then I'm going to draw it for us. And then I'll set up the poll to have you solve it. This is the last one we're doing today. I appreciate you hanging in there with me so far. And I want you to be able to try to solve this one. If you can solve this one, you're doing fantastic with what we've worked on today. And like I said, content-wise, for some students, this is the most challenging section we cover all semester long. So if today's going really well for you, if you're getting it, then you can feel pretty good about the next, couple of months. If you're struggling a little today, I think that's normal. Don't panic, don't get discouraged. These get much easier with practice. And you can ask me questions now and by email and on Thursday. So don't get discouraged. I'm going to go ahead and draw this for those of you who haven't. The angle of elevation, as soon as I see that, that means I'm going to have an angle that is up from horizontal. From a spot on the street to the top of a building, so it goes to the top of a building. There's my building. It doesn't have to be pretty, but there's my spot at the top of the building. And that angle is 67 degrees. The distance from that spot to the base of the building is 30 feet. Rounded to the nearest hundredth, how tall is the building? So what we're looking for is this side right here, which I'll call X. I know an angle and I know one of the sides, so I can find it. I've got my right triangle here, and this is the angle I know. Let's see, I better label things. This side's my hypotenuse. That's the angle I know, so that is opposite. And that means this one down here must be adjacent. What's important when I go to use SOHCAHTOA is which two sides am I using in this particular problem? And here in this particular problem, what I'm using is, well, let's see, adjacent is the one that I know, and opposite is the one that I'm looking for. So the ones that I'm using here are opposite and adjacent. So that's the trig function I look for in my SOHCAHTOA. Sine is opposite hypotenuse. Well, I'm not using hypotenuse, so that's no good. Cosine is adjacent in hypotenuse. Again, I'm not using hypotenuse, so that's no good. So it must be tangent. And tangent is opposite over adjacent, and those are the two that I care about in this problem. So tangent is a trig function. Oh, dang it. I didn't set up the poll. Y'all should have stopped me after I drew it. I got carried away. I'm going to set up the poll right now. All right, here goes. Okay. So I gave you more than I wanted to after I drew that picture. That's okay. You go ahead and complete that poll for me and let me know how tall the building is. Again, if you can solve a problem like this, then you're doing fantastic with the trig component of class today. If not, it doesn't mean you're failing. It just means you're going to need more practice, and that's okay. I do think drawing the pictures is really important. And I'll mention that after we finish this one up. I'll have a couple of things to say before we close. So we're almost done with what we did there in drawing the picture and labeling the sides and figuring out that we were going to use tangent. I didn't mean to give that away. I apologize. Some of you may have been way ahead of me anyway. I'm going to go with that. I'm thinking we'll go another 30 seconds and then talk about it. If you want more time, just let me know. All right. Yeah, I'll leave it up there for a little bit. Oh, that's unfortunate, Matthew. That stinks. It does happen sometimes that, technology lets us down. I apologize for that. We're almost through, and so those technology issues can go away. Oh, okay. So Kevin meant a different answer than he gave. That happens sometimes. Sometimes you hit the wrong button. It's good to let us know because that gives me some information. Let's see where we are on this one. Okay, pretty strong agreement on that. And we know there's one that is also that same answer. Very good. That's outstanding. Okay, I'm impressed with your performance on this. That's terrific. Okay, let's go ahead and finish this up then. We had decided that because it's opposite and adjacent that we were going to use tangent. And so the tangent of that 67-degree angle is going to be opposite, which is the thing we don't know, over adjacent, which is 30. Variable in the numerator. Woohoo! All right, tangent of 67 degrees is 2.3558 52366. And that's going to equal x over 30. And the really good news here is with my variable in the numerator, which is not up to me, it's just how the problem worked out. I need to multiply by 30 on the left and the right. On the right, they cancel, leaving the x. And on the left, that number that's already on my calculator, I just need to multiply by 30. And when rounded to the nearest hundredth, I get 70.68. So that's the height of the building. A lot of people got that correct in the poll. That's fantastic news. All right, just a couple of things before we finish today. I know this is a long class meeting. When you're working on these problems in section 1.4, don't be in a hurry. There's a process. We're going from words to a picture to an equation, and then we're solving it. Variable might be in the denominator, which means we got to write down all those numbers in the decimal. It's okay. Don't be in a hurry. Draw a good, accurate picture. Try to draw a really good picture of what it is that's going on, because that's going to help you set it up. Whether it's a tree that's fallen over, an angle of elevation, an angle of depression, try to draw a good picture. Identify what you know and what you're trying to find. What I mean by that is opposite, adjacent, and hypotenuse. Figure out which one you're looking for, figure out which one you know, and that's how you'll decide on the trig function to use. And then also, don't do any rounding until you get to your final answer. It's never fun when we have to write down a really long decimal like this, but we want our answers to be as accurate as possible. And along those lines, we're going to keep all the decimals until we get to the very, very